Hello, today we're gonna talk about the configuration of VPN server into Oracle Cloud. Uh, we you want to access your private instance, and we have some options here, like using the Bastion servers with the SSH keys. So I did have a problem with the Bastion servers because even using the right SSH keys, I couldn't connect to the instance. And since the Kubernetes cluster was that we deployed in the last video, it's using private instance, so the instance will be available to the internet only through the load balance. And if you want to access the instance for maintenance or some curious thing we're going to do with the instance, we need access to the private network. Oracle has a VPN product. If we go here in the networking, we do have a site-to-site VPN, but that is more aligned to business owners who want to connect your business network with the Oracle Cloud. They also have Fast Connect, which is a dedicated line of connection with Oracle Cloud. It is also aligned to business. The dynamic routing gateway is one of the options to route traffic through your connection to your network with the Oracle. But I did want something lighter, so unfortunately the Bastion server didn't work for me. It's free and it would get the job done. But what did work was in the virtual cloud network. So you want to have access to your private subnet. And what did work for me was to use Twingate. I did find about Twingate while searching for solutions for interacting with the Oracle Cloud private network, but they do offer a lot of value to access on-premises network and other types of networking. The Twingate, it works a little bit different than a VPN server because you did have a kind of mesh VPN which you connect directly to the network instance, but there is also another VPN solution called Zero Tier that I used to use in some configurations. But the problem with Zero Tier that you need to access the instance and install the software, and then it will connect the machines in a mesh VPN. A mesh VPN is different from a VPN server because you don't have a centralized server to communicate, so your traffic can go directly from one machine to another without going to a centralized server, so you gain in performance and in latency. So for me that didn't have access to the machines, it didn't work because we have to have SSH access to the machines to provision the software, which I didn't have. So what Twingate works is that you deploy a virtual machine with access to your virtual private network, and with that machine you connect your network with other clients, and you pass through this virtual machine, and everything it has access to, you can provide access to your devices. And it also has policies and other kinds of security measures, so you didn't have to give full access to all devices and users of your VPN solution. So it's a little bit different, and it works with my problem because I didn't have to install anything on the VM servers to begin with. So if we compare, traditional VPN has a VPN server where the manager servers that you want to connect in a local network will communicate with the VPN servers, and the clients, like the business managers or the client that are outside the LAN network, will interact with the internet connection encrypted and will go through this VPN server and you will access your machines that you're exposing to the clients. The OpenVPN is a good solution for that. I did have some issues with OpenVPN, like the management side is not so good because it's a lot of things you need to do to get up and running. And with solutions like ZeroTire and Twingate, it's more easy to manage. You don't need to manage not anything. It just works plug and play. So we have talk about Oracle Private Network. With that, we want to access virtual machines in the subnet that we created, 10.0.1.0/24, and we have some virtual machines that we want to access. In this case, the two machines that we provision the Kubernetes cluster, and one vault machine that we'll talk about later, that it's security encryptor software that we are provision for the secrets of the Kubernetes applications we want to deploy. So we want to access that. It's on a private network, and for that we want to provision a Twingate VPN, and it's the only VPN that needs a public IP address, and it will connect your machines through the servers. The way it looks like, if we look at the Twingate overview, we do have a controller which is hosted by Twingate, which is the software that controls access and controls how you're gonna communicate with the connectors. The connectors are the machines that you deploy. You could deploy in many ways, like using Docker or using a VM, dedicated VM, and the connector will give access to the client. So the connector is, in this case, in this example, in a AWS network, or you could have a connector in a on-premise network. The connector provides authentication using the controller, and the client apps that we have Android, macOS, Linux, and Windows clients, you create a TLS tunnel using a relay component here, and this relay component will connect to the connector, and the connector will connect to the machines or private resources that you have. You can also delegate authentication to ident provider like Okta or G Suite, but I'm not using that. So this is an overview of how Twingate works. And We have free bastion servers. We talk about architecture. We talk about traditional VPNs. So let's see what are the features of Twingate. To get started, it's free. So I have one network here. So my network is a group of resources that you deploy, and you can have in the free try two remote networks. Remote network is a place where you deploy the connectors to connect to. So I create a remote network called Oracle Cloud. The global network is like your organization, it's your account you create, and you could have many remote networks that you control access to, like on-premise network. You could have it configured here. If you do have a public network in cloud environment, you could have it added here. So if you just sign into Twingate, you create a network. In this case, I use the other network. It doesn't matter too much which one you add. So if you look at network is the basic of Twingate. In the network, we deploy the connectors. Twingate recommends deploying 2 connectors for each network because it will fail over if the connector it's not available, and it will load balance the traffic between the connectors. So you can add more connectors here, but it recommends 2. I use just 1 because I am the free tier of the Oracle Cloud, and I just want to use 1 virtual machine to deploy this connector. And for me, it's fine because the availability of this virtual machine it's enough for me. But if you are concerned about the availability of your network, a high ability network, you should add 2 connectors. So if we going to deploy the connector, it will give you some instructions on how to deploy. You can use a Docker, or you can use Helm. You can deploy the connector to Kubernetes to access the internal servers of the Kubernetes. You can add a Azure virtual machine. You can add a Linux network, or you can add AWS. Manually, you can specify how to generate a token, and you will add the servers manually. In my case, I use the Linux command, and the connector will deploy a system servers. So in the installation, you go to your Linux machine and you copy this command after you generate the token. This command will set up for Debian or RPM like systems like Oracle Linux or the CentOS Linux. So it's just that easy. You just copy and paste this. I launch a virtual machine in the public key network subnet, so I give a public access, and I did in a little different way. I did that using Pulumi as a code. Pulumi is a software that it's like Terraform to create virtual machines and to create networks and infrastructure for in the cloud environment. I like Pulumi because you use a language to express your your resources. In this case, I use a TypeScript, but you can use Java, Python, and other languages. So I did create one Twingate virtual machine here using the API for the Oracle Cloud. So it will create a instance in the first available domain with the compartment ID that I provided as an argument, and it will add in the public subnet. In this case is Twingate VPN. It has a fault domain or default in the fault domain 1, and it gives my SSH public key, which is an argument to the Pulumi configuration, and it uses the shapes of standard micro. It has 1 GB of memory and 1 CPU, and the boot volume is 15 GB, which is the minimum, and use the Oracle image ID. I need to know what is the ID of the image in my region in order to create the VM. So in the case I'm using Oracle 8, and that's it. I just run Pulumi up, and my resource will be created. It's just like Terraform. It's very easy. One advantage that I like is because the Terraform, you need to provide a way to deal with the state of the Terraform. If you need to use a different machine, or if you need to share your Terraform files with others, you need to provide a way to store the state of Terraform. In Pulumi, this is done for you for free, and they provide the servers in the cloud for you. So you just create your account and they run infrastructure for you. But you don't need to do that. You can go create an instance in the Oracle console if that is best fits for you. So after you create an instance and a network, you sign into a network, cloud and remote network, and you ready to deploy a connector. In this case I'm using Linux, and you just run the command and you should be able to connect to your remote network. By doing so we have talk about network, and let's talk about teams. In the team, I have just one user, but you can create groups and you can delegate admin access to some groups. I think in the free, let's see in the free if you can create. We can create up to 5 users, and you can have 1 device per person. So we can create 5 users here. So on your network, after you create your users and after you create your team, you can enforce policies. I forgot to mention one thing that is important here. After you connect your connector, you need to create some resources. By default, you don't have access to your resources unless you add it here. So I add a private subnet, added the public subnet and the private subnet to a list of resources. You could add one machine at a time, or you could add the whole network. So when you add the network, you are able to give access to your users to this network. And you can add a resource by DNS name, and you can add a CDI block. If you add a resource as a DNS resource, it will forward the query to the connector, and it will resolve this query and return to you the IP address of the resource. Okay. So we talk about resources, we talk about things, and some policies. So I didn't create a policy, but we can see the default policy. The default policy requires authentication every 5 days, so you can force your users to authenticate and not let the VPN open all the time. And you can add two-step verification for your clients. You can add a device as a trusted device. There is some resources that you could put here and just make available for trusted devices. So you make sure that even if you allow a user to connect, it will not connect in another device unless you allowed it. Let's check what we can have in the policy. Well, you can have, if you don't want your users to connect through Android or iOS, you can disable here, or Linux or Mac OS or Windows. And that's it. That's not too much about policies. I think they will improve that policy to give more flexibility. So devices, every user who connects and installs the connector user who installs the client will have a device name here, and you can trust the device or not, and you can add a policy to only trust devices connect to certain resources. And you can add a minimal requirement here for the device. For instance, you can add a Windows that has no antivirus, or you can require antivirus in the Windows. That's good to know. So biometric configuration, you can require it in the iOS or in the Android. And we do have some identity providers that you can configure for the authentication. You can connect to Okta, Google Workspace, and the Azure AD or OneLogin. You can connect these providers so you can log in. And also the users can log in with a Microsoft account, as you saw in my login attempt. So the pricing for Twingate, you can have a free account. Can have up to 5 users, 1 device per person, and up to 2 remote networks. And for teams, you can have up to 15 users and up to 2 devices per person, and up to 5 remote networks. It's $5 per month. You can have a business plan with 10 users per month, $10 user per month, up to 150 users, up to 5 devices, and up to 10 remote networks. You can save in the yearly commitment. First, let's talk about alternatives. As I mentioned, Zero Tier is a good alternative. I don't recommend running your own VPN server, but if you have the IT to manage that, go for it. But it's headers to maintain. And we can search for. We have WireGuard, which is VPN tunnel in the Linux kernel, and we have WireGuard, and it's fast and secure tunnel VPN, but you do have to manage the keys to connect to the server. But you have on top of WireGuard, we have Tailscale, which is a managed server which facilitates the user of WireGuard connections. So you just install and you don't have to worry about connecting with the server. So you just install Twingate on all machines, will be connected, and you can configure using no configurations. You don't have to open a firewall port. It bypass NAT in the systems. I recommend you check out Tailscale as well as an alternative. And let's demonstrate how to use Twingate. So currently I have Twingate installed here. It's easy to install, just download the client. So I'm going to log in Kubernetes. I will log in my network here. Okay, after install and login, you can check the resources you just created. For instance, Kubernetes node, you can copy the address and ping this address. So we saw that we connect to the IP address that is different than the resource, but we still have time to live quite small here. And we can connect. This is a DNS resource. If we add the IP address, I think the connection will be even more directed. So add a private network here. Let's check the IP address of the Vault server. Private P endpoints. So if I ping this IP address, I have even small milliseconds because we don't need to go through different servers. I think let's check. Trace out. So it's a direct connection as far as I can tell. It passed through the deployed connector, but should be good to go. So let's see the MTR for the resource. Is also a direct connection, don't pass to a gateway. Oh, it passed to a gateway. But that's it. It don't a lot of gateways to interact to. It goes more direct, like a local network, as expect for a VPN. So it's very simple. There's not too much to know here. Let's check the connection to the vault. So I'm using my private DNS to connect. You can see that I added the resources here to the vault server. I need to add, if I want the DNS, the downside, because if I want a DNS, I need to add one by one. So vault private network. But as you see, I can connect just fine. So this vault does not have a public IP address. So that's it. Thank you for watching.